At B and C, we just plug in, no, at B, 1 plus e raised to negative 1/3 sine 4/3, no. That would lead us to a value of 1.696424. For f of c, just it's the same process, no? We just replace x with 2/3, no? So 1 plus e raised to negative 2/3 sine 8/3, no? Giving us a value of 1.2347772. We now have all those needed for the formula. We just plug in, no? That's 3 times 1/3 over 8 times the summation of 1 and 3 times 1.696424 and 1.234772 plus 0.721588, giving us the estimated area as 1.314397 units squared, no? It's indicated here as the green area, no? If you can still see, there's still some error, pero sobrang minimal na niya compared to the previous two, no? Now, let's move on to using naman Boole's rule, no? Denoted by the formula here. We just get H first, no? We're working with 5 nodes na. So, the denominator would become 5 minus 1, so 4 minus e. The numerator is e minus a. So that's 1 minus 0 over 4. That's 0.25. No. From a, we have 0. No. A plus h, that's b. No, that's 0.25. A plus 2h is c. No, that's 0.5. A plus 3h is 0.75, and a plus 4h, that's 1. No? Evaluating a, b, c, d, and e at f of x, no? From the previous 3 calculations, we already have f of 1, f of 0.5, and f of 1, f of 0, no? We just have to evaluate b and d, no? So at b, no, f of b, that's just 1 plus e raised to negative 0.25 sine of 1, no? At f of c, f of d, that's just 1 plus e raised to negative 0.75 sine of 3, no? Now, we have all the requirements, no, for the formula. We just have to substitute, no? That would lead us to 2 times 0.25 over 45 times the summation of um, f of a, f of b, f of c, f of d, and f of e multiplied to their respective weights, no? That would lead us to an estimated area under the curve being 1.308592, no? It's denoted here by the green area. Kung may nakikita pa kayo na light blue, then that's the error, no? Now, we solve, no, analytically so that we can compare the error of each formula, no? If we integrate the function 1 plus e raised to negative x, sine 4x from 0 to 1, no? Analytically, we can solve this, no? It's just x plus negative e raised to x sine 4x minus 4 times e raised to negative x cosine 4x over 17 plus c. No? How? We just use, no, um, integration by parts, no? That's, um, since u v minus the integral of v du, u dv. No? Integrating that would lead us to this one. No? 1 is integral of 1 dx is just x. No? Then we evaluate, no, at 0 to 1. No? So we just plug in 1 sa x, then minus when we plug in 0 naman sa x. No? So 1 plus negative e negative 1 sine 4 minus 4e negative 1 cosine 4 over 17 minus um 0 plus negative e negative 0 sine 0 minus 4e negative 0 cosine 0, no, over 17. No? That would lead us to 1.308251 units. No? That is the um non-approximated area under the curve. If we table the values, no, from we got from earlier, no, from the trapezoidal rule, we got 0.867094. No, from Simpson's one third, we have 1.321276. From Simpson's 3/8, we have 1.314397. Boole's rule got 1.308592. And from the analytical method, we have 1.308251. No? If we just get the error, no, so that's the difference between the analytical method and the individual areas, no, we computed. The largest error is the trapezoidal rule, no, since the function that we chose is not linear at the interval 0 to 1, no. Then the next one, no, with the second highest error is Simpson's one-third rule, since it's not also a function that is fitting the second order polynomial. The next is Simpsons, then the last would be Boole's, no? Since um the we talked about earlier the trade-off of higher accuracy, no? So lower error, higher accuracy, lower error, so more computations, no? We have 5 nodes here. We calculated from A to E. So it's befitting that we got a lower error compared to the previous three na we used, no? That is all. That would be the end of lecture 3.1.